Hello everyone, welcome you all in this class. Today we are going to discuss equation of progressive wave. Equation of progressive wave. A wave is traveling along the x-axis. The displacement of the particles in y direction. Let us consider P is a particle. It is mentioned along the path of the wave. The distance of this particle is x from the point of O. So the displacement of this particle is indicated along in y direction. Here is the displacement of this particle. The displacement of this particle from its mean position. The displacement of a particle from its mean position at any time t. Hence the displacement of that particle equation is given by y equal to a sin omega t. Here is a very simple, you can try to understand this. Where the particle is indicated along the path of the wave, it is getting vibrations. So it is getting vibration from its mean position. At the distance is x from the point of O at any time t. Hence displacement of this particle equation is given by y equal to a sin omega t. And the next part is when the wave reaches the particle P. When the wave moves to the particle P at a distance is x. Distance is x. After a time t. Hence the speed of the wave v equal to x by t. Here is the wave is traveling along the x direction. We know that when it reaches to the particle P after a time t, hence the speed of this wave can be written as v equal to x by t. Now the time taken to travel along the x-axis, then the time t is equal to x by v. T equal to x by v. Here at x equal to 0, the earlier time is taking. Here what is the earlier time? The earlier time is mentioned, that is t minus x by v. X equal to 0. At x equal to 0 means at the distance will be 0. At the time of we considered earlier time, the earlier time is taking, that is t minus x by v. So this earlier time can substitute it where the place of t in the first equation. Okay, after it can be changed. The displacement of this particle wave equation can be changed. So how can it be changed? See that. And y equal to a sin omega. In the place of t, we are taking t minus x by v. T minus x by v. Okay, this wave equation is represents when the wave is traveling along positive x direction. So the general equation can be written as general equation. The general equation is y equal to a sine omega t plus or minus x by v. This is the general equation of progressive wave equation, and we have to modify this equation. How to make modification of this displacement of wave equation? Y equal to a sine, here omega is multiplied with this omega t plus or minus omega x by v. Here y equal to a sine omega t plus or minus omega x by v. Here omega by v is nothing but propagation constant. Since k is equals to omega by v, we know that already discussed in the previous class. Now here is kx. So this equation is called as progressive wave equation. Okay, y equal to a sine of omega t plus or minus kx. Now next topic is various forms of progressive function. Various forms of progressive function means the different types of progressive wave equations. So what are the types of progressive wave equations? How many types of progressive wave equations? Here is the first one, y equal to a sine omega t plus or minus kx, or y equal to a sine of omega t. Here is kx plus or minus omega t. It can be written as like this also, kx plus or minus omega t. So the different types of wave equations, the different types of progressive wave equations, I am writing here. Y equal to a cos omega t plus or minus kx, or y equal to a cos kx plus or minus omega t. Third one is y equal to a sine. We know that omega, but omega is nothing but a 2 pi by t. 2 pi by capital T time period. Here is into t plus or minus propagation constant k equals to 2 pi by lambda. It can be written as 2 pi by lambda into x. Now here is y equal to a sine, we should take common 2 pi. The remaining part is small t by capital T plus or minus x by lambda. All are in general equations of progressive wave functions. Y equal to a sine 2 pi of t by capital T plus or minus x by lambda. If here is the plus sign is taking in all the equations, all equations are represents when the wave is traveling along the negative x direction. If we will take the negative sign in this equation, only the negative sign is represents in these equations. All equations are represents when the wave is traveling along the positive x direction. Here, now y equal to a sine 2 pi of, here is, we know that v is equals to n lambda, but here is v equal to lambda by t. We need to take capital T. T is equals to here lambda by v. V equal to lambda by t, but t is equals to lambda by v. Where capital T, I can substitute lambda by v. Here a sine 2 pi of small t by capital T. Capital T is nothing but lambda by v. Here is vt by capital T. Vt, capital T is equals to lambda by v. Here lambda by v. Here lambda by v. Means vt by lambda plus or minus x by lambda. See that y equal to a sine 2 pi of vt by lambda plus or minus x by lambda. Capital T is equals to lambda by v. So that's why I substituted here where the place of capital T, here is a lambda by v. V will go to up and vt is divided by, here is a lambda. Right? And the plus or minus here same as it is x by lambda. Here that is equal to a sine 2 pi. A sine, this is fifth equation of progressive wave. Y equal to a sine 2 pi by lambda into t plus or minus x by only just x. Here is only vt. Vt is there, no? Vt plus or minus only x. Because of the lambda is taken in outside, no? So that's why 2 pi by lambda. So the wave equation is given by y equal to a sine 2 pi by lambda of vt plus or minus x. Plus or minus x. This is sixth equation. So also we can write it as y equal to a sine 2 pi by lambda of vt plus or minus x. It is one of the type of progressive wave function. So next seventh one is y equal to a sine 2 pi by lambda is k. A sine k of vt plus or minus x. It is also one of the type of wave equation. So next one from equation 5. Where is 5? Here is y equal to a sine 2 pi of vt by capital T plus or minus x by lambda. Y equal to a sine 2 pi of vt by capital T plus or minus x by lambda. So here v is equals to lambda by t. We need to take capital T. T is equals to lambda by v. T is equals to lambda by v. So here is lambda is equals to what? Vt. I can write it. These conditions in this place. Y equal to a sine 2 pi Vt by capital T. Vt by capital T. Here Vt same as it is Vt capital T plus or minus x by lambda. What is lambda? Lambda is equal to, here is Vt. Now x by vt. Here y equal to a sine 2 pi by t, taking common, and the remaining part is t plus or minus x by v. This is eighth equation. Y equal to a sine 2 pi by capital T of t plus or minus x by v. It's very simple. Vt by capital T plus or minus x by vt. Where the place of lambda, we substituted lambda equal to vt. That's it. So the equation becomes y equal to a sine 2 pi by t. Here is the common capital T, here is capital T is there. That's why we have taken the common capital T in outside the bracket, 2 pi by t of t plus or minus x by v. That is how the equations are be changed step by step. Here ninth equation, y equal to a sine. Here 2 pi by t is nothing but omega. Omega of t plus or minus x by v. Here you can multiply 10th equation, y is equals to a sine omega t plus or minus omega x by v. 11th equation, finally y equal to a sine omega t plus or minus omega by v is nothing but kx. Finally, the first equation what we have written, that equation is came. So that's why all of these equations, progressive wave functions. Write these equations completed. Okay. When we'll add pi in that equation, y equal to a sine omega t plus or minus, here is kx plus pi. If plus pi means the vibration of particle reaches at extreme position, at the time of it comes from mean position, which makes an angle of pi, which is pi by 2 from the bottom, y equal to a sine omega t plus or minus kx plus pi by 2. Here, since pi is equals to pi by 2, the vibration of particles reaches towards the extreme positions. At the time of the phase of the wave is taken as pi by 2. Here where the pi by 2 is added in that equation, so the displacement of the progressive wave equation can be written as omega t plus or minus kx plus pi by 2. Here y equal to a cos omega t plus or minus kx. This is the common. If the wave is moving along the positive x direction, like this, when the wave is moving along the positive x direction, it can be written as y equal to a cos omega t minus kx. Here negative sign represents the wave is moving along the positive x direction. If y equal to a cos omega t plus kx, it represents when the wave is moving along the negative x direction, but especially it represent this wave equation is represent wave is traveling wave is traveling along negative x direction. Negative x direction. If plus sign is mentioned, it moves along the negative x direction. If here minus sign is mentioned, your wave is moving along the positive x direction. It represents wave moves along positive x direction. Positive x direction. The common formula, the general formula is used as y equal to a cos of omega t plus or minus kx. At time t is equals to 0, at time must be constant. The time interval should be constant. So the particle getting vibrations when it is moves upward and it comes downward direction. At the time of the total phase of the wave is taken as pi. The phase must be pi. So we can write the progressive wave equation y equal to a sine kx plus or minus omega t. Here is means we can take only pi. No, here pi is considered pi means 180 degrees. In the radian is pi. So a sine of kx plus or minus omega t plus pi. So we can write y equal to a cos kx plus or minus here omega t. Kx plus or minus omega t. So because of when the wave is moving along the positive x direction like this, wave moves in this direction x, the displacement is in y direction. So y, and when the wave is moves along the positive x direction, when moves it like this, so the wave equation can be written as a cos kx minus omega t, kx minus omega t, like this. In the sine curve, in sine curves are mentioned like this, y is equals to a sine kx minus omega t. Or we can write like this also, y is equals to a sine, here is taking common omega, here means x by v minus t, also we can write. It is also one of the equation when the wave is moving along the positive x direction, we can write the propagation wave function y equal to a sine omega of x by v minus t can be also written. Next one is, so when the wave is traveling, suppose if y equal to a cos kx plus omega t, it will take like this. So this equation is represents the wave is moving or the traveling along the negative x direction. So it represent wave moves along negative x direction. Negative x direction. We know that we can write it y is equals to a cos of kx plus omega t, or y equal to a cos omega of x by v plus t, like that also we can write. No? So this equation is represents the wave moves along negative x direction. Because of here is plus sign is indicated, we represented plus sign here, that's why its equation is represents the wave is moving along negative x direction. Very simply remembering, If negative sign is mentioned here, the wave moves along the positive x direction. If here is plus sign is mentioned or here is plus sign is mentioned, at the time of the wave is moving, the equation is represents the wave is moving along the negative x direction, like this. Write these equations. It will take the negative sign, wave moves forward. If we will take plus sign, the wave moves backward. Variation of phase with the time. A wave is traveling along the positive x direction, the displacement is y. Here wave moves along the positive x direction. The time interval between the 2 points, that is delta t, is taking. And now pi at time t1. Here is the distance of the pulse must be constant when the wave is moves along the positive x direction. Here distance is constant. The variation of time is taken at time t1. The phase pi of t1 equal to 2 pi of t1 by capital T minus x by, here is x by lambda, plus total the phase of the wave is pi. It is one of the equation. And pi, the time taken t2 equal to 2 pi of t2 by, because of the variation of time, no, when the wave is moving along the positive x direction. That's why we are taking the phase of that wave at a time t2 is equal to 2 pi of t2 by capital T minus, here is x by lambda, total phase of the wave is pi. So what we have to calculate here? Variation of phase with the time. Time is not constant here. Only the distance of the wave pulses are constant. Here phase, variation of phase is nothing but the difference of phase. Delta pi equal to pi of t2 minus pi of t1, that is equals to pi of t2 is this one, 2 pi of t2 by capital T minus x by lambda minus of 2 pi t1 by capital T minus x by lambda. Here is pi, here is plus pi, here is plus pi. This one cancel, and this one cancel. The remaining part is 2 pi by capital T, okay, of t2 minus t1 minus x by lambda plus pi. Here is minus of minus, here plus, no, so that's why plus x by lambda. Here is x minus x by lambda, here plus x by lambda. Here is plus pi, here is minus pi. Will be cancelled. Here is cancelled already. Okay, the remaining part can be written as 2 pi by capital T of t2 minus t1. That is 2 pi by capital T, t2 minus t1, that is delta T, time difference. So here is therefore delta pi equal to 2 pi by capital T into delta T. Phase difference, which is equal to 2 pi by capital T into time difference. This is time difference. Right, it's a phase difference is equal to 2 pi by t into time difference. This equation is very important. Its formula is very important. Phase difference is equal to 2 pi by t into time difference. Next one is variation of phase with distance. Variation of phase with distance. Here is with distance means here pi of x1 means time must be constant. Time is constant here. At constant of time, pi of x1, that is equals to 2 pi of t by capital T minus, when the wave is moves along the positive x direction, t by t minus x1 by lambda, the total phase is pi, can be written as like this. T is constant, the variation of time must be constant, the variation, the distance can be changed. When it is changed, the distances, the variation of phase with the distance. So here is pi of x2, that is 2 pi of t by capital T minus x2 by lambda, here is pi. So same as this, the equation is can be written as the phase of the wave at the distance is x1, the phase of the wave at the distance is x2. The time must be constant initial phase, at initial phase and the next phase. So here is delta pi, here is x2, here is x1. The phase difference delta pi equals to pi of x2. So what is that equation? 2 pi of small t by capital T minus x2 by lambda into, here is x2 by lambda plus pi minus 2 pi of small t by capital T minus x1 by lambda plus pi. Here after multiplying with minus, here plus pi get cancelled. Here what? Minus 2 pi. Here t by t. This one cancel. The remaining part is delta pi is equals to 2 pi by capital T. Here lambda. We should take common. 2 pi by lambda of x2 minus x1. The remaining part is x2 minus x1. Here is 2 pi by lambda into delta x, change in distance, that is delta pi. So finally this is therefore the phase difference. Phase difference is equal to 2 pi by lambda into path difference. Phase difference equal to 2 pi by lambda into path difference. Write these equations. So the final formula is what? Phase difference is equal to 2 pi by lambda into path difference. Thank you very much.